Hong Kong has millions of electronic devices, such as remote controllers, clocks, and laser pointers. All of these devices are powered by batteries, which are toxic. So we like to replace these electronic devices, the batteries, with solar cells. So for example, this is a laser pointer driven by solar cell, powered by solar cell, will save Hong Kong a lot of money and also save the environment of Hong Kong. Conventional inorganic solar cells are very complicated to produce, and they're very expensive. As a result, the contribution from solar cell to global energy demand is only about 0.1%. It's very small. So we need a new solar cell technology that is easier to produce, that is cheaper. So we developed a new generation of organic solar cell materials that have a very unique temperature-dependent aggregation property, which enables several important features for our solar cells. First of all, our solar cells are more efficient. Number two, our solar cells can make thick film devices, which makes roll-to-roll printing. You know that newspaper printing is one of the fastest, cheapest, and most efficient production methods, just like the printing of newspapers. Number three, our materials can control organic solar cell morphology very well. As a result, we can use cheaper materials. We can reduce the cost of solar cells. With these materials, in the past 2 years, we broke world records for organic solar cell multiple times. And our latest record sale was noted in the famous NREL chart. NREL chart records the 40 years of history of all different types of solar cells. For solar cell researchers, appearing on this chart is a great honor. So this is actually the first time Hong Kong appears on this chart, something we should be proud of. So how we came up with this idea? Actually, lots of breakthroughs, and they were not made by design. Instead, they were made by maybe careful observations. So the temperature-dependent aggregation property of our polymers. In 2013, in an undergraduate student's experiment, we observed this for the first time. And I found this highly interesting. I believe it will be useful. So I decided to switch my whole team to start to make a series of polymers with similar temperature-dependent aggregation properties. As a second step, we like to use our solar cells and as the window for buildings, and also put solar cell on top of cars, in car window, to help generate electricity. So this is the future of solar cell technologies.